We'll turn in Friday. All right. So this, I believe, is the last day of notes, and then you're just going to practice this like crazy Thursday and Friday. So by the time Friday, end of the day rolls around, you're going to be a killer. Hopefully you are already. Reminding you, do you all see where I'm at on the notes? I think you're on the very last page of the notes, right? So number 6, y equals a to the x when the base is greater than 1. Remember, when you do exponentials, it matters if you're multiplying something greater than 1 times itself, it'll get bigger. But if you took a half times itself over and over, it would get smaller. So if a is greater than 1, it's exponential growth, right? Give me 2 important points on that graph. Let's start with this one. 0, 1. Every exponential, unless it's shifted or stretched, crosses through 0, 1. The other point is the one that comes from the base. And it's that one. When x is 1, y is a to the 1, or a. That's the one that tells you what the base is. 2 to the x, 3 to the x, 4 to the x. And what's the asymptote? The asymptote, you can see right there in the highlighted, says you need to provide 2 essential points and an asymptote. So make sure if the graph gets shifted, you show a dotted asymptote. Where is the asymptote here? 0. Y equals 0. All right. Now let's talk about then 2 to the x. We've been doing that a while. Give me 2 essential points. 0, 1, and 1, 2. We have room for another point. Give me another point. 2, 4. Okay. After that, we're kind of off the graph. Exponentials grow pretty extremely. And on the left, we're approaching the asymptote. Okay? Please don't curl away from the asymptote. It should approach the asymptote. It's not a parabola shape. All right, so B then. Let's talk about taking that base graph and changing it. What does a negative outside the function do? That changes the function, which is to say it changes y. So will that cause it to flex side to side or up and down? What kind of y's will you get? Positive or negative? You're going to get negative. Negative y's are down here. So if the negative is outside the function, it changes up and down. So instead of 0, 1, we're going to get the point 0, negative 1. Instead of the point 1, 0, 1, 1, 2. Instead of the point 1, 2, we'll get the point 1, negative 2. What's another point? 2, negative 4. And then the asymptote is still, oops, the asymptote is still at the x-axis, yeah? Okay. What's the domain, the range of that, please? So we need a little more practice on range. Yeah, it's lowest to highest. So what's the lowest y? Negative infinity to the highest y? 0. Okay, negative infinity to 0 is the range. We do need to practice that. What would the domain be? Negative infinity to positive infinity. All right. In C, there's a negative causing reflection, but this time it's on the x. If you change the sign of x, that changes it side to side. That makes sense. X is a side to side kind of thing. So if I reflect side to side, then give me some points on 2 to the negative x. 2, 1. Let's go with the easy one. Where's across the axis? 1, 0 or 0, 1? 0, 1. All right. Let's go to, we say it's reflecting this way, right? So shouldn't there be a point at negative 1, 2? And that makes sense. 2 to the negative 1 is just 2 to the 1. And so it feels like it's been reflected and it's growing on the left and decaying on the right. You follow? Let's talk about how that makes sense. Isn't 2 to the negative x equal to 2 to the negative 1 to the x? What's 2 to the negative 1? 2 to the negative x is exactly the same as 1/2 to the x. And doesn't that decay to the right? You follow me? Okay, maybe a bit of an overreach there. I feel like I lost some people there. But catch back up. So, did you get out a whiteboard and a marker, please? We need to practice this. Search markers. I just going to take forever here. It's fun to throw, but sorry. Guess you don't get a throw. What'd you graph on the whiteboard? 3 to the negative x plus 1. Sorry to drop my muscle. As always, think, what's the base graph and how has it changed? Take a test point. Does it say anything? Tonight's homework. This is how you do essential Okay, so you're going to want to do, show me 2 points and the horizontal asymptote once you're done. Okay, so label 2 points and the horizontal asymptote when you're done to make it like preparing for the homework. So, do you agree 3 to the x has essential points of 0, 1, and 1, 3 before changing? Alright, so what does the negative do? On the x, because it's on the x, it changes x, so does that change it side to side or up and down? Side to side. So now it's going to go this way, yeah? And then what does the 1 do? Moves it up 1. Now let's consider the baseline, and if you move it up 1, then isn't the baseline, instead of being at the axis, it's going to be at 1, yeah? So you should have a horizontal asymptote at 1, or like 1, and your points. This point was at 0, 1. When it reflected, it was still at 0, 1, and then it got moved up 1. So where is it now? 0, 2. You should have a point at 0, 2. This point that was at 1, 3 got reflected over to negative 1, 3, but then up 1, so now it's at negative 1, 4. Now, rather than just trust my graph, let's actually think about, does that point work on the graph? If you put in negative 1, what's 3 to the negative negative 1? What's negative negative 1? 1. 3 to the 1 is 3, plus 1 is 4. Is that checking out then? When I put in negative 1, I get out 4. It all makes sense. So you always have the, can I put it into the equation and verify my graph, and it should work. You with me? All right. Let's try e to the x. What is, that's an exponential. So give me an essential point. 1, 0 or 0, 1? 0, 1. Does the order matter? Yeah, order matters. Okay, so 0, 1. What's the next one? 1, 2.7 or 1e. 1, 2.7 is there. And the asymptote is at y equals 0, yeah? Okay, so the points are 1 above the asymptote and 1 to the right and about 2.7 above the asymptote. So if I say in D, sketch y equals e to the x plus 2, I'm going to take that same shape and move it up 2 or left 2? Left 2. So the asymptote, will it be the same place? If it's left, does that vertical part change? Or does it just stay 0? And what about the point here at 0, 1? When you move it left 2, it moves to negative 2, 1. And what about the point 1e? When you move it left 2, where does it move to? If we move it left, is the x going to change or the y? The x is going to change only. So 1 minus 2 is negative 1e-ish. So this point is negative 1e. You follow? All right. What about y equals e to the negative, the opposite of e to the x minus 3? What does the 3 do? Shifts it right 3, so I'm going to be over here. I'll nail it down in a second. Then what does the negative do? Flips it over the sideways or up and down? Up and down. So it would be something like this guy. So now we need to get it a little more exact. What about the asymptote? Where's the asymptote? It's still at 0 because it was not vertically changed, yeah? What about this point 0, 1? Where did it go to? Take me through its changes. 0, 1 was shifted right 3, then reflected down. So where does it end? Gosh, man, that's hard. Let's go slow. When I move it right 3, what does it become? 3, 1. Then when I move it reflected down, what does it become? 3, negative 1. Does that check in the equation? If I put in 3, don't I get e to the 0, which is 1, and then tack on a negative? So it seems like it's cool. What's the other point then? Gosh, it was 0. It was 1e, right? When you moved it 3 over, what did it become? 4e. And then when you reflected it down, what did it become? 4 negative e. And I obviously drew that really badly because 4 negative e would be for about 2.7. Yeah? My graph is kind of, my points are not really good. You follow? Okay. Let's, should we go back and scratch this again, try it again, or just go on to this one? All right, so what do you reckon we should do here? Factor it. So it's e to the negative x minus 3. All right, so now, what would the 3 do? This is the curve to begin with. What would the 3 do? Right, 3, so we're going to go 1, 2, 3. And then what would the negative do? Flip it over the axis or just across the essential point? Across the essential point. So I feel like eventually it'll be like this. All right? Now let's take an essential point to check. It says, seems like my essential point is at 4, 1. Do you agree? Do you agree? I don't know how I got 4, 1. It was at, sorry, it was at 0, 1, and I added 3, so I drew it badly. It shouldn't be at 4, 1. It should be at 3, 1. Silly goose. I moved it too far. 3, 1. Let's check that in our equation. If I put in 3, I get e to the 0, or negative 0. E to the negative 0 is e to the 0, which is 1. So is that point at least in the right place? Okay. Now the next point, I'll check my reflection. This other point was at 1e, yeah? And when you moved it right, it's going to be moved 3 to the right, so that puts it at 4e. Then when you reflect it, it's at 2e. So that point should be 2e. Let's check. If I put in 2, you can even go back to the original equation. If you put in 2, e to the 3 minus 2 is e to the 1. We're good to go. Right? All right. Is this difficult or no? This is great. Why do I even ask? All right. Go to the whiteboards. Let's see how you do. You're gonna do great. You're so smart. Let's see how we're doing. What does the 1 do? Left 1. Okay, so now this point, if I look at the original curve and move it left 1, doesn't that make, what does that make this point? Negative 1, 1, and it makes this point, I didn't draw it well, but if you move it left 1, wouldn't it be at 0e? My graph is obviously terrible. It should be at the axis. You with me? Then what does the negative do? Does that go side to side or up and down? Up and down. When the negative is outside, it causes it to go up and down. So the final curve in green looks like this. So I'm going to go there, and this point, negative 1, 1, ends at that point, which is negative 1, negative 1. You should have a point at negative 1, negative 1. And this point here, which was at 0e, gets made to 0, negative e. So that's 1, 3 maybe here. And it's still going to approach the y-axis like that, yeah? Negative 1, negative 1. 0, negative e. And again, we could check. How do I check? Yeah, plug that x in and see if you get that y out. If I put negative 1 in for x, I get e to the 0. Negative e to the 0 is negative 1. Seems cool. If I plug in 0, I get e to the 1. Negative. Seems cool. All right? Are you with me? All right, let's go to log. Ooh, yikes. All right, this we definitely need to review on because some of you are not so great at log. I guess that's probably my fault. Log are the exact opposite of exponentials. So instead of the 0.01 that we normally get on exponentials, we get on log 1, 0. That's one essential point. On the exponential, we typically then get one base, or 1a. Well, on the log graph, then we're going to get, instead of one base, we get base 1. Graph is base 1. You show the base then at a y of 1. Because log base b of b would be b to what power equals b, and that's the 1 power. All right. And there is an asymptote at x equals 0. I love that you said x equals 0, not just 0. 0 by itself is not an asymptote. It's a number. An equation of an asymptote has an equal sign in it. All right. So log base 2 of x minus 1. What's log base 2? Give me some critical points or essential points on log base 2, no shift. All log graphs have 1, 0. And log base 2 would have, instead of b1, log base 2 would have 2, 1. So there's what log base 2 would look like before shifting. And what does the 1 do? To the right 1. So let's start with the asymptote. Isn't the asymptote going to be shifted right 1? So now you're going to have an asymptote, instead of at the y-axis, it's going to be at x equal 1. Yeah? And then the point 1, 0, shifted right 1, comes 2, 1. And the point 2, 1, 2, 0, sorry, 2, 0, yes? Let me start again. This point at the axis, it was 1, 0. Do you agree? It got shifted right 1, so that puts it at 2, 0. This point that was at 2, 1 got shifted right 1, so where does that put it? 3, 1. So the graph looks like that. Okay. Log base 2 of x plus 1. Log base 2 of x looks like this. 1, 0, and 2, 1 before shifting, and then the 1. What does the 1 do? Up 1 or left 1 or right 1? If they want it in with the x, they'll put it in parentheses, so you can assume that's like log of x done, and then the 1 is after. So is that up 1 or left 1? Up 1. So it's up 1. Up 1 is cool because it doesn't change the asymptote. It's still there. Right, Mr. McCabe? Right. So when you take the point 1, 0 and shift it up 1, what does it become? 1, 1. When you take the point 1, 2 and you shift it up 1, it becomes, sorry, 2, 1 becomes 2, 2. 1, 1 and 2, 2. Okay, put those better. All right. Let's try a negative and a reflection in there. Okay, so y equals log base 2 of x, again, we know is 1, 0, 2, 1, heading down. What does the negative do? Reflect it side to side or up and down? Up and down. So if you reflect it up and down, then what point doesn't change? 1, 0 is still there, 1, 0. What about the point 2, 1? When you reflect it down, if you reflect it down, the x stays the same, the y changes, it becomes 2, negative 1. All right? 4, 2, and so on. All right, let's see how you do. Try this on the whiteboard. Y equals log base 3 of x minus 1. make sure you give me the two essential points and also give me the vertical asymptote. ¿Listos? No, okay. I guess I can. Yeah, please do. Okay. A lot of success, I gotta say. I'm pretty impressed. The points for log base 3 are originally 1, 0, and 3, 1, because the base is now 3, not 2, yeah? So what does the 1 do? Right, left, up, or down?
Right.
Right. So instead of the asymptote being at the y-axis, now the asymptote is at this line. So tell me, if you said vertical asymptote is 1, is that the asymptote? No, that's half asymptote. You don't want to do half asymptotes, right? You want to do full asymptotes. What is it? X equals 1. That's a full asymptote equation, okay? 1 is not an asymptote. It's just a number. All right. What about this point 1, 0? When it's shifted right 1, it's 2, 0. So you should have the point 2, 0 as an essential point. And what about the point 3, 1? When it's shifted right 1, the X will change. It becomes 4, 1. So you should have those 2 points and an asymptote of X equals 1. Cool? Natural log. That's like log base what? No, that's common log. E. Or if you like, log base 2.7. E is this naturally occurring number like pi, 2 small, a lot of different math fields. But you've got the point 0, 1 to begin. No, what is my problem? 1, 0 is still on the log graph because it's still a log. And the other point that shows the base here is E1 or 1E? E1. The asymptote is still X equals 0 or Y equals 0? The vertical asymptote is X equals 0 unless it gets shifted, which it will. So, Y equals log of negative X. Does that negative cause shifting, stretching, or reflecting? Reflection. Does it cause it to reflect across, side to side, or up and down? Side to side. So, if we reflect side to side, does the asymptote change, or is it still at the axis? Okay, what does the first critical point 1, 0 get flipped to? It flips over. The x's are changing so from positive to negative, so it gets flipped from positive 1, 0 to negative 1, 0. The x is opposite, so the x changes, negative 1, 0. What about the point E1? What's changing, the x or the y? The x. So if we change the x sign, it becomes negative E1. And the asymptote is still x equals 0. Are you with? No way. All right. Natural log of x plus 1. Shift, stretch, reflect. Which one? Shift. Right, left, up, or down? Left 1. Let's start with the asymptote. It's shifted left 1, so now the asymptote is at x or y equals? X equals? Negative 1. The vertical asymptote is now at x equals negative 1. The point that was at 1, 0 gets shifted left. And if it's shifted left, the x changes. What does 1, 0 become? 0, 0. All right? Moved it left 1. What about the point E1? When you shift it left 1, the x changes or the y changes? X changes. If it was E and you subtract 1, then now it's, what's E minus 1? 1.7. You can call it E minus 1 or 1.7, whichever you prefer. But that point is now e minus 1, 1, and the other point is 0, 0, and the shape is log your nature. Okay? Alright, log of x plus 1 outside, no parentheses. That shifts it right, left, up, or down. Up 1. Does up 1 change the vertical asymptote? No, so it's still there. What about the point 0, 1? If it gets shifted up 1, what changes, the x or the y? The y. So x stays 1, the y changes to 1. I said it wrong, but you get the idea. What about the point E1? What changes if I shift it up, the x or the y? The y. If I change the y by 1, it becomes E2, 2.72. E2, 1, 1, cha-cha-cha. All right, try this one. I think that's all she wrote. Or no, maybe it's all she wrote. All right, go, Whiteboard City. You're not doing so hot? You're doing great. This is effort. This is a formative assessment. You're forming your knowledge, not evaluating. Use your checkpoint. Once you get what your graph you think is, then put the point into the equation to verify. So let me say this. Maybe it would help to do this in a slightly different order. What if you reflected first? Then instead of this, it would look like this, yeah? And then shift it which way? Right, 2. So is that better to reflect first? Does that help you more? I don't know. Okay. No, there's just 2 things going on. That 2 is not a lot. 2 is very little. Okay, so do you agree that natural log, what do you want to do, reflect it first or shift it first? I heard both. Okay, so right 2. Do you agree then that the asymptote is now at 2 and that main point is now at 3? All right? And then instead of this way, we're going to reflect it. So this point gets reflected over to 1. All right, now let's talk about that other point. Because it's with the, not over the axis. So, good question. If I reflected all the way to the axis, that's a good question. It actually wouldn't work. If I ended up over here, if you said, now it's at -3, -3 minus 2 is -5. Log of +5 is not at all what I should have. It's just reflected over the asymptote, not over the whole axis. It doesn't work the other way. All right? So I'm getting a shape like this. Cool? And this point is pretty easy. This point is 1, 0. Back to 1, 0. What's the other point? Phew. It was, what did it start at? It started at E1. Do you agree?
Yeah.
Then we shifted it right to, so that's, what? They're all confusing me. Do you agree on the original graph, the point is E1?
Yeah.
Okay. Then when you shift it right to, isn't it E plus 2, 1? Then you reflect it over, it's over here, instead it's, I'm waiting for it. Maybe I'm going to be waiting forever.
Negative 1.7.
Negative 1.7 or negative 0.7?
0.7. If we're already at 1, it must be 2.7.
Okay, so it was 2.7 right of 2. Now it's going to be 2.7 left of 2. 2.7 left of 2 is negative.
No, because that's only 1.7, right?
No,
No,
it's 2 from, it was, oops. The asymptote was at 2, and our other point was 2.7 away from it, yeah? Now it's going to be flipped 2.7, the other side from 2, 2 minus 2.7. That's where they're getting negative 0.7. Think of it in relation to the axis. So negative 0.71. That went great. Here we go. Really quick, just verbally, tell me what does the 3 do?
move it left.
Left. What does the 4 do? Horizontal squish. What does the negative do? Flips it up and down or side to side? Up and down. What does the 2 do? Stretch. What does the 5 do? Down 5. Alrighty. That went super. Great job. You guys have to do enough for homework? Okay. Good energy. Good energy. Alright, make sure I get my markers back, please. Does everybody have an R and a Q? You're going to do all of R and half of Q, right?
Yes.
Right. We're almost into the textbook. I think it's, your next test is next Thursday, and then after that we're pretty close to the book. Textbook, textbook. Oops. Okie dokie. All right. Here we go. Oh, have a great day. Be nice. Thank you. Have a good day.
Thank you.
Thank you. Thank you. Have a good one. Sorry it was difficult. No, you're not. Don't say that ever again. All right. See ya. Peace out. Francine. that copy that. Thank you. All right. Students. Okay.
Literally the first thing I did when I left, I was like, every morning. Oh yeah, there is a lyric in my grade, you're right. Yeah. No, that was it.
All your power.
Yeah. Every month.
The dance is like this, so when the guy keeps his flag, it's supposed to like, you might wear the costume smile, like, be back.
They just took a fire. Time for cleaning.
So you should know. You're like,
My mom
He
came.
walked. He pushed it up the mountain.
Like an hour.
Yep. He's not working.
What? Kelly left here right away, so she's asking.
Hey guys, we're doing the.
Well, I wouldn't know, I guess I.
Wait, what? What? I ate American cheese. I except for the Alps. Okay, cool. How are you all today? More tired, although I slept more hours. Oh, well, maybe you slept too much. What?
What college did you go to?
I went to Kansas, then CU, then. No, that's my daughter. And I took a semester at UCB, and I took some. So after I graduated from CU, but then I would just kind of miss school. And I'd say, gosh, I miss school. So I'd just go and take a course, take a course. And you guys take for granted that you learn everything. It's so awesome. You're going to miss it. You're going to miss it. If I were rich, I'd just be a professional student. I'd get 50 degrees. All right. 2, 7, and 8. Then I went to UNC, and I took some classes of mine. Phew. I have classes at like 9 different schools. Sure, I don't care. I don't have to try a degree, just pick up a class. All right, so you can probably get it from the book just as quick as I could write it up there. You're on set 76, number 2, 7, and 8. Are 2, 7, and 8 changed in your problem set or straight up normal in the book?
They're normal.
Right, normal 2, 7, and 8, please. I'm on page 2, 3, 94. Oh, that's my new page. It's changing when it's raining.
It's fine, I don't want to do it. Whatever. Thanks, Skylar. Oh, yeah, why don't you do that? I'll just sit here. You can go off.
Do you need a book?
No, Skylar's using my book.
What the heck?
Skylar needs it.
Are you getting bullied?
You're my book.
Okay.
My book is cooler than yours.
That's just how I am. So, the 2 probably won't matter because when you use force, it's all about Y. But that'll matter for your force. Oh, when you do yeah, pretty much. Right, yeah, you got it. Yep. Correct. On those force problems, you can always use your calculator to evaluate as you understand when that's why E is. Hey, what's good? Oh. In this case, the axis was drawn for you, so you do not have to have a picture. If the axis is not located for you, you do need a picture.
I just got the same function as the other twice and I haven't read.
How are we doing? Are we on 2, 7, or 8?
2, 7.
Okay, that's a nice picture.
I'm very
Good pacing. How we doing? The majority about there? All right, cool. They say no child left behind, but in this class, you get left behind. Child left behind, Kylie.
I am always left
You're gonna
behind.
be left behind.
I literally haven't solved one yet, so.
You haven't done,
No, I tried it. It was just really wrong.
okay, well, at least you care about it being right. All right, on to, do you agree the big idea of fluid force is rho dA or PdA, where rho is the weight density? What's the weight density, Harper, what's the weight density? All right, per cubic meter. When you talk depth, that's the depth of a slice. That's always the surface of the fluid, not the container top, minus y. So, show what you say for surface minus y. Number 2. What did you say? 3 minus y. Thank you. Okay, cool. When I say area, does that mean bust out the trapezoid area formula?
No.
No, it means what's the area being applied to this line right here? And that is x dy, but x can't stand. I need to replace x with y plus 6 all over 3. The limits of integration, 0 to 2 or 0 to 3? 0 to 3. I don't know why they would do 0 to 2. I'll just do that afterwards. Does somebody give me a number? 102,000? 900, no digits. 102,900 newtons? Okay, cool. 7, I wish I would have reviewed continuity a little bit. So you gotta, I know we talked about this in the review part of the class, but when you do continuity, do you say the limit as x approaches c from the left equals the limit as x approaches c from the right equals f at c, or you do the more actual formal definition, f at c exists or is defined, the limit as x goes to c exists, which is to say the one-sided limits are the same and those two are equal. Which of those, the first or the second, do you employ?
Depends on the problem.
Okay. This is formal math. This is probably the way you would be taught it in a college setting. This will hold water in the AP test and in my class, so it sounds like most of people did this in the first way, yeah?
Yeah.
All right, the limit as, so in this case the problem was 7, okay. Oh, actually you are improving continuity here. I do want to include what I would expect to see on such a problem. X squared plus 1. Look at your work, please. If your work looks like this, did he say greater than 0 first? What in the world? Why would he go right to left? What? Why would he do that? Okay, at any rate, if your work looks like this, people, 0 plus b equals 0 plus 1, write this message to yourself. Boo! You stink. That's terrible calculus. That's not even calculus. That's numbers. Okay? Boo! If you think it works, then you're saying it got you the right answer. Did it get you points on this problem? No. Did it get you points on the test? No. So it depends on if you're doing this for you or for me. If you're doing it for me, that stinks. All right, now then, the limit as x approaches 0 from the doggone it, he gave you the right-hand side first. So is that approaching 0 from the right or the left if I use it? The right. 2x negative 2x plus b equals the limit as x goes to 0 from the left. Why would he do that? That's so weird. That is the required first step. Then, actually, step back here. The first thing I really looked at, I didn't say it just now, but I did look at it. The first thing I actually looked at is one of these equal to? Because if one of these is not equal to, it's a really easy problem. What do you say?
No.
It's not continuous because either because f at c doesn't even exist and therefore can't equal anything, or by true definition, f of c is not defined. So look there first. It is there, so now let's proceed on to there. Negative, what do we got there? B then equals 1. Is that all you had to do? Oh, that's so easy. Okay, 8. 8. At least tell me you have to prove continuity there. Yay. Okay, so this is a fill the hole problem. X cubed minus 8 over x minus 2 when x is not 2. Is this right? Is this looking correct? Okay. I'll give you $1 million if you can tell me what that first part of the graph looks like. And by $1 million, I don't really mean I'll give you $1 million. I'll give you an attaboy. What is it? It's a parabola with a hole at 2. Shoot, I'm glad I took back the $1 million. But attaboy. All right, so it's a parabola with a hole at 2. Cool. Now the question is, did they fill the hole? Well, let's go here. First of all, so you say the first. All right, let's go. What about the limit? Do I need to go one-sided limits or can I go two-sided limits?
Two-sided.
I can go two-sided limits because it's the same for left and right. When x is less than 2, we use this. If x is more than 2, we use that. So let's just go both are, what is this? The limit as x goes to 2 of, do you remember how to factor cubes? So x squared plus 2x plus 4. The x minus 2 drops out. Why did I have 2 of those? All right, so x squared plus 2x plus 4 evaluated at 2 is 12. Did they fill the hole? No. So we conclude f is not continuous because the limit as x goes to 2 of the function is not equal to, actually I'm just going to be really good and say that's 12, and that's not equal to f at 2, which is 16. Somewhere in there tell me why you say it's not continuous, and it's because the limit and the point. Are you with me?
Yeah.
Cool. Today's lesson, you might have noticed that this note sheet, if you look at it front and back, it's actually 2 note sheets at once. What? There's 2 integration techniques to be learned. One is, these are pretty nice and to break it up. Most times you just do it in one day. But set 76 is integrating odd powers of sine and cosine. And set 83, I think, I can't remember, is set even powers of integrating. All right, so let's talk about this here. I should have been recording so well, it's not too late. Okay, so in order to integrate stuff like that, you need to remember some identities. And I'm not talking some obscure who remembers that identity. I'm talking about the big ones. What's sine squared equal to? 1 minus cosine squared. And cosine squared is 1 minus sine squared. So that's not going to take any studying on your part. I'm sure those are already in there. Now, when you go to integrate an odd power of sine or cosine, the whole idea is you split it up into pieces and then use of it. So you're going to split this into sine squared and sine. Now, the symbol, this to the first one, will become du in a minute. And I'll explain how. You'll see how. You probably see how now. If that's going to be your du, then you should probably change this to something u-ish. And if the derivative is sine, then the original function probably needs to be cosine. So you replace sine squared with 1 minus cosine squared. So that now you can use stuff. Let's let u equal
1 minus cosine.
I don't want to go the whole thing. U is cosine u, cosine x. Why did I have? Sorry, these should be x in there. U is cosine x. Yeah. You with me? So what's du? Negative sine x dx. And so when I go to substitute this is 1 minus u squared, and that sine of x dx is actually not du, but negative du, or the opposite of u, and how you deal with that negative is your call. You can put it out front, you can change the signs here, whatever you want to do. Let's go, what do you want to do? You want to put it out front or change the signs in here? Change the signs in here it is, all right. I don't even ask you, you decided, I just assumed you decided correctly, but you chose wrong. All right, u squared, what's the antiderivative? Yeah, I didn't mean to imply you did have a choice, you don't. What's the antiderivative of u squared? 1/3 u cubed. What's the antiderivative of 1 with respect to u? Plus a c. And then this is an indefinite integral, so I do need to step back. The final answer is 1/3 cosine cubed minus cosine of x plus c. Really? All right. So it's when you have an odd power, you split a single off and you use sub. Let's look at this a little more complicated. You would use this in conjunction with other skills, smaller skills. So like this. What would you do first, you reckon? Split it. Okay, so you would split it up into cosine squared of 4x and cosine of 4x. Then what? Cosine squared to 1 minus sine squared. Again, still go with 4x. The cosine of 4x single stays. Then what are you going to reckon? That u equal sine of 4x, so du is 4 cosine of 4x dx. With substitution then, the binomial becomes 1 minus u squared, And what about cosine of 4x dx? What does it get replaced by? 1/4 du, yeah? Well, see where we're coming from? Okay. So what's the antiderivative of 1 and u squared? Cubed over 3 plus c. So when I sub back, my final answer is 1/4 of u gets replaced back with sine of 4x minus sine cubed of 4x over 3 plus c. Does that make sense?
Yes.
All right. Now, those are odd powers, but when you bump up the power, it's a little harder. So what do you reckon on cosine of the 5th? Cosine to the 4th, I heard, and cosine. And then what did you say about squaring? Which then? One minus sine squared, which you could write squared or write it out if it helps you to. It helps me to have it written out so I don't stand binomial wrong. So. The expansion is 1 minus 2 sine squared plus sine to the 4th, if I'm not mistaken. Do you concur? All right. Now, u sub. U is sine of x, and du is cosine of x dx. So with substitution, the trinomial is replaced by 1 minus 2u squared plus u to the 4th, and then just a straight up du outside. Right? The antiderivative of which is u minus 2/3 u cubed plus 1/5 u to the 5th plus c, and then sub back sine of x minus 2/3 sine cubed of x plus 1/5 sine to the 5th of x plus c, and that's all she wrote. Cool? Okay, and then again, just little gradually getting a little more wrinkles here, but none of these are very hard. You'll be. Cosine squared sine cubed. What would you do? I actually kind of told you. Darn it. Did I tell you that on your note? I did. Why am I holding your hand so much? Stop holding my hand. Do it on your own. I'm giving you too much. So when you split, you always split the odd. Okay? You wouldn't split cosine squared into cosine. That doesn't do you any good because then what are you going to do with the other cosine? There's no identity for it. So you always split the odd. This then, what do I replace? Cosine squared or sine squared?
Cosine squared.
Cosine squared. Okay, that's a great forceful answer. It's wrong, but good try. What's your du?
Sine.
Du is sine. So what does u need to be?
Cosine.
Cosine. So everything needs to be
Cosine.
cosine. So what do you replace? Yeah, this needs to be replaced. This is your du. If your du is sine, then all else needs to be cosine. So as far as what you replace, you want to make everything cosine-ish besides the du. So cosine squared stays. Sine squared gets replaced by minus cosine. And then the sine is going to be your du in a minute. It's your choice. Do you want to expand or u sub first? I don't know. Okay, it doesn't matter if you u sub then expand or expand then u sub. It's going to end up in the same place. So if you probably less writing if I sub first, but hold on. U is
Cosine of x.
cosine of x. Du is
Negative sine of x.
negative sine of x. If there's a place to be careful, that's the one when that negative pops up. A lot of errors are made there. Be careful there. Upon substitution, then, this becomes
U squared.
u squared minus u to the fourth times du or negative du? Negative du. So I guess you could say, if you want, you could say this is u to the fourth minus u squared positive du. If you want, it's up to you. I took that negative in. You follow? The antiderivative is 1/5 u to the fifth minus 1/3 u to the third plus c. So final answer 1/5 cosine to the fifth of x minus 1/3 cosine of x plus c. Okay, last one.
Go. All of the above.
I probably should have done a little more simplified. I think there's one in the homework anyway. The answer is it doesn't matter. It doesn't matter. So which one do you want to split? Okay. Doesn't matter. So cosine. If you say split the cosine, then you're going to have cosine to the fourth, sine cubed, and a single cosine off to the side. If you do that, then what's your du?
Sine.
Du is
Cosine.
cosine, so everything else needs to be sine. So if, again, the thought process for your notes is if du is cosine, make all else sine. So, that kind of sucks. Maybe we should have split the other way. Now I'm going to have to expand a binomial, right?
See, that's what I'm
Maybe I should have done it the other way. Too late, keep going, or keep going? Those are the stubborn people. Those are my
I jump
brethren.
off the train.
Screw it, let's just keep going.
We never said we're gonna be late.
1 minus sine squared squared, sine cubed, cosine, yeah?
Yes, good. So that's the one.
What is 1 minus sine squared expanded, and then do you want to do this in one step or two? Two? So much writing. Sine squared. You guys are not at all good at being lazy.
I wasted my brain cells.
All right. So with the expansion, you got sine cubed minus 2 sine to the 5th plus sine to the 7th. Do you concur with the cosine dx outside? Yay? Unless I made a mistake, which is entirely possible. Are we cool? Let u equal sine, which implies du is cosine. At least we didn't get that negative problem in there. That's cool. So the integral is u cubed minus 2u to the 5th plus u to the 7th du. Not me again if you made a mistake. I made a mistake or you're not sure what I'm doing. What's the antiderivative? 1/4 u to the 4th minus 2 6th u to the 6th plus 1/8 u to the 8th plus c. At the end of the day then 1/4 sine to the 4th minus 1/3 sine to the 6th plus 1/8 sine to the 8th plus c. Now you might ask, what if you have gone the other way? Wouldn't this answer all be in cosine terms? The answer is yeah. And you might say, how could they be equal? They are equal because the constant is different. The constant integration will be a totally different constant integration. So it is possible that what you're getting is sine, but they get cosine in the back of the book, and that happens once in a while. Just be aware it's not a problem. If you're not sure if your answer is okay, just ask me and we'll walk through it. All right? That's it. You with me? Cool. All right, questions on set 75.
So many questions.
So many questions?
Number 25.
10, 25, 2, 10, 25, and 2. 10, 25, 2, 3, did I hear? 10, 25, 2, 3, 6, 7, 15, 9, 25, got that. 4, 4. Dude, I think with so many questions, I would have a lot of you in 7th period. But could be wrong. I have
Your
questions
seventh
about
period was
set
crowded
A.
yesterday. Your seventh
Yeah.
period was full.
Yeah. Yeah, it's getting rough. Things are getting rough. You got to be aggressive in your question asking.
What's this number
2 on the back?
What do you mean? What's this number 2 on the back?
What do you mean?
Why can't I have a number 2 on the back? Just follow the pattern. If it seems like it's missing a number, just think about it. It's 26.
There is a random 2 on the back.
I'm not bound by your
Oh, that one.
clarity. Oh, everything's got to be so clear. Okay, 10. You still need 10 people on
Yeah.
75. Okay, 7510 is 5 the max and min of. Does it say anything as far as a note in the box? Did I say you had to use the EBT and AP? Let's do this in a formal way, shall we? Okay, x2x on the interval -2, 3. Do you read this as absolute extrema or relative? Absolute. Absolute extrema must be at endpoints or critical points. And critical points are where f prime is 0 or undefined. Do you agree? Okay, now for an absolute value graph, that's going to include those flex points where it gets flipped. I am visual, so I need to graph this. Isn't the graph of this looking something like a parabola with zeros at 0 and 2, and therefore a W shape? We?
Wow.
All right, f of x. Do you want to write the f of x piecewise, or do you want to just go straight to the derivative? Write the f of x. Good deal. Let's go and methodically. Wouldn't you agree that for x is less than 0, this was not sign change. It's normal x squared minus 2x. For x between 0 and 2, the function wanted to be negative, but the absolute value made it positive. We took the opposite sign, so in there it was actually the opposite, 2x minus x squared. How are these absolute value derivatives going? Is this going okay? Okay. For the far right side, x greater than 2, that also is not flipped, no change, it's normal x squared minus 2x. Now, what about the endpoints? Should I include them on the function somewhere? Do those points really exist on the graph? They do, so they need to be included somewhere. Now, if I want to go to the derivative then is 2x minus 2 for x less than 0, 2 minus 2x for x between 0 and 2, and 2x minus 2 for x greater than 2. Do you agree? I just took the derivative of each piece. Stop me if I'm going too fast. You with me? Okay.
Okay.
Okay, now my next point is the critical numbers. Let's start with undefined. Where is f prime undefined? 0 and 2. Because those are sharp terms, right? So those are critical points. Where is f prime equal to 0? At 1. So we have 3 critical points in addition to the 2 endpoints, assuming they're all in the interior, which they are. All right, you with me? All right, so now we let the candidates fight it out and see who wins. F at negative 2. What's f at negative 2? Looks like the absolute value of 4 plus 4. Seems to me like it's 8. Are we good? The next point, I'm just going left to right. The next point I come to is f at 0. What's f at 0? 0. Then f at 1. What's f at 1? Absolute value of 1 minus 2 is 1, yeah? Then f at 2, which is another 0. And then f at 3 is the absolute value of 9 minus 6, or 3. Do you agree with my critical, my candidate y value? All right. Now we conclude, making sure we answer the question properly. Does it say at what x, or what is the max value? And it says what is the max value. The max value of f is 8. The min value of f is 0. Is that good? Any questions? Yes.
Could you find that one of the critical points is at 1 by like looking at the graph? Yeah.
Good question. It kind of goes to the homework versus the AP test. On an AP test or a college test, they would never say, look at my graph for 50. That's not the look at the graph is never kind of. On the homework, you're thinking, and that's fine with me. Just know on the test that would be. Good question. Thank you for asking. All right, 25. Is 25 still a question?
Yes.
All right. The hardest part of this is getting started, really. The calculus is not too bad. It says the nearest point. So would you please categorize what kind of problem is this? It's not a distance problem. Think calculus. It's optimization. Find the closest point. You're trying to minimize the distance. All right. What is a distance equation? Distance is, now we have actually equations from a distance from a point to a line, which is not what this is. You should think point to a point, but what's the other point? Yeah, it's lots of possibilities. It could be here, or here, or here, or here, or here, but generally speaking, it's a varying point, x and y. That's the hard part, is naming that point, because it's not given to you. It's abstract. It's in the abstract. So isn't the distance then x minus 1 squared plus y minus 0 squared? So after you ask, what am I doing, you then get an equation. Then we talked yesterday, the optimization process says, get it down to 2 variables. Right now it's 3. So what's another relationship to get it down to 2 variables? Y equals the square root of x, which would be cleaner. Feels like that looks good the way it is, because then at least square root of x squared is just a normal x. Right? That'll keeping it this way keeps you from getting something in the fourth. So use this. Distance is x squared minus 2x plus 1 from the expansion, and then the square root of x squared is just another x. Do you agree? So I'm going to call it x squared minus x plus 1 to the 1/2 power for my distance equation. Are you with me? Pause or go ahead?
Wait. Oh, yeah, okay.
Okay. This came from square root of x put in and split. Cool. Now, we do our calculus. We want to find to find a minimum, we want to know where d prime goes. -2. Positive for a min. Isn't that a minimum? Okay, so what is d prime? 1/2. This thing to the -1/2. Are you down? Are you down? Okay, times the derivative of the inside. 2x minus 1 is 0 and undefined. Are you tracking? Okay, pause for thinking. This would be undefined if the denominator is 0. Tell me why the denominator cannot be 0 in this case. That denominator comes from the distance. And is that distance ever 0? Yeah, no. So I could look into this and say, are there any zeros? But then I have to do all that quadratic stuff. You're wasting your time. It's not 0. I can just tell you right now, there is no undefined point. That's gone. Now let's just focus on the top. What's the critical number that makes the derivative 0? Before that, you'd have a negative. After that is a positive. So it feels like, yep, we're getting them in. Now let's make sure we answer the question. Does it say, what's the point closest, or what's the minimum distance? What does the question say? Question says, find the point on the curve closest. So we have half a point. When x is 1/2, y is square root of 1/2. There's our answer. That's the closest point. And it looks right visually. You with me? Okay. 2. Hay una pregunta number 2. Número 2. ¿Sí o no? Sí. Señor. All right. This is starting to make me mad. Okay. So, number 2, look at your work. If on number 2 you don't have an integral anywhere, your work will get you a big fat 0 on a test. You didn't show a jack nothing of calculus, okay? It's not recall from physics, the equation. It's use calculus to find. So I better see calculus, integrals. The acceleration due to gravity is -9.8. The velocity, isn't the velocity then the antiderivative of that? Yeah? So, v equals -9.8 t plus a constant. Notice I'm not just throwing in the initial condition. To me, that also is bad calculus. It says when at the initial velocity of time 0 is time 10, that tells me that the equation is -9.8 t plus 10. I know at this point you're thinking it's so stupid, it's kinetic. I know it's 10. It's not always 10. On some movement problems that aren't projectile motion, it's not the constant is the initial. It's not. You're just lulling yourself into a false sense of security. So, now we're ready to find the height. Height is the antiderivative of velocity. Hey, there you go. There's some more calculus. Negative 9.8 t plus 10 integrated is negative 4.9 t squared plus 10t plus a new constant. I wouldn't take off if you didn't use C1 and C2, but that's just how I was taught. So I think it's good calculus. Communicates they're different. It says from the top of a 200-meter building, so that's 200 equals 0 plus 0 plus C2. Height is negative 4.9 t squared plus 10t plus 200. Are you down? Okay, now the question. Develop an equation that expresses, did that. How long does it take the ball to reach the ground? Gosh, when you do air resistance, these actually require differential equations, so that'll be cool. But for now, we're just going to go with it. Hits the ground. What does that imply? Ground implies height is 0. You absolutely may use your calculator to solve this. Whether you use the solver or you just type in the quadratic formula, if you have a program, however you choose to do it, you should give me the positive root, obviously, the negative solution. It doesn't make any sense in terms of this problem. Are we cool on 2? 3. Is 3 still a question? Does anybody need 3 still? Okay. How about 6? 6.
Yeah.
6 is a yes. Whoever needed 3, if you need me to go back, let me know later. 6. Describe the interval. Oh, this is a good one. Okay, so 6 is a little bit of a test for brilliance here. X squared minus c squared over x minus c when x is not c. Am I doing that right? No. When x is not negative c. And 2c when x is negative c. Okay? This is about continuity, eh? So the limit as x approaches negative c, what is it? As x approaches negative c, I divide out of x plus c. Negative c minus c is negative 2c. Negative 1c minus 1c is negative 2c. So the temptation is to say this needs to be continuous only if the limit equals the point. And so negative 2c needs to equal 2c. So did you conclude that this is not continuous at x equal negative c, so maybe negative infinity up to negative c and negative c to infinity? Yes?
You sound really fast.
Okay, sorry. Do you agree that the limit is negative 2c? That's a whole. And the point they put on is that when x is negative c, the y is actually 2c. Did they fill the hole? They did not fill the hole. So it's not continuous because the limit is not the same as the point. So it would be logical to conclude it's not continuous at x equal negative c. And so the intervals where it is continuous is basically everything except. Test for genius though. Unless c is 0, then are they? If c is 0, is it continuous? Yeah. So let's assume that c is not 0. But if c were 0, if c equals 0, then continuous at all reals. Okay? That's a good one. 6, check. 7. Question on 7. Does anybody, who's with me, still need a question? What do you want me to do? 7, okay. I'm just being shy of 20 seconds. but now you're over it. All right, so 7, a rectangular, did I replace that or is it normal? No, it's normal. All right, a rectangular, where did you put your origin? At the bottom left corner of the rectangular prism?
Yep.
Okay, cool. It says it's 4 meters deep, and it's filled up to that. The width is 5 meters. Cool. And it's filled with something with weight density 5,000. All right, so what's your basic equation for a force? Rho dA. Rho is 5,000. What did you say for the depth of each slice? 4 minus y, I agree. What did you say for the area of each slice? That's the area of each of these. 5 y. 5 y. All right, make sure I get this by the end of the day. Make sure you put your names on that. You're good. Have a great day, my friends. Thank you, thank you, thank you. It's a great day.